Hello, today we're going to evaluate an integral. This is a trigonometric integral. Just by inspection, we can't see an easy way to just integrate this, so we're going to have to use a few tricks. So the first trick is we have cosine x raised to the fifth power. We can rewrite that as cosine x raised to the fourth power times cosine x. Then we can use a trig identity. We know that sine squared x plus cosine squared x equals 1, or cosine squared x is the same as 1 minus sine squared x. So let's go back to our integral. We had the integral of cosine x raised to the fifth power dx, and we said that was cosine x raised to the fourth power times cosine x dx. Here we have cosine x raised to the fourth power, which is basically cosine squared x raised to the second power. So we can rewrite this integral as 1 minus sine squared x, which is what we decided we're going to use for cosine squared x. And that's squared, since that we showed above, is cosine squared x squared again, now is cosine x to the fourth power, times cosine x dx. Then we can use u substitution to evaluate this integral. Let's use u equals sine x. Then you need to find du dx. So du is the same thing as cosine x dx when you differentiate that. And I'm going to plug in now for u. So this becomes integral of 1 minus u squared du. So we saw basically that our du became cosine x dx, which is here. So you just need to evaluate the integral. Here we have 1 minus u squared raised to the second power. I'm going to expand this. So 1 minus u squared times 1 minus u squared is 1 minus 2u squared plus u to the fourth power. So our integral is 1 minus 2u squared plus u raised to the fourth power du. And integrate each term. We got u minus 2/3 u cubed plus u raised to the fifth power over 5 plus some arbitrary constant c. And you can finish by just plugging back in what we used for u. So u was sine x. So we have sine x minus 2/3 sine x raised to the third power plus 1/5 sine x raised to the fifth power plus c. So this is how you can evaluate a trigonometric integral. Just to recap, we had integral of cosine x raised to the fifth power dx. We wrote an equivalent expression in terms of powers of cosine x. Then we used a trig identity to re-express cosine squared x as 1 minus sine squared x. And then we used u substitution to evaluate the integral, and we got our final answer below. So I hope this helped. Thanks for listening.